Hi, today we're going to look at some logic gates and how to turn Boolean equations into logic gates. So, first off, if you remember from our previous video, we had a not, an and an or as our basic operations of what we can do in Boolean algebra. So, if we want to turn that to a circuit, we have to have some sort of gate that represents those operations. The three basic ones are on the top here. So, first off, we've got the not gate. You can see that we have a on the left, and if we put that in here, it's going to act like it's a not gate. So therefore, we're going to get a not coming out. Pretty simple. The left side here is the input, and the right side is the output. And that's going to be true for all these gates. So if I have an A here and a B here, well, on the other side, that's going to be A OR with B, because this is an OR gate. Finally, for the AND gate, if I put an A here and a B here, I'm going to get AB, because this is an AND gate. So it's going to do the AND operation on A and B. Now, there's some special gates that we have, and they're going to be used very often. We have a NOR gate and a NAND gate. What this basically does is this adds that same bubble that you see over here. So let me erase this real quick. What this bubble does here, this bubble, what this does is if you have something coming in and it comes in across into a bubble, it's going to jump over that bubble and get knotted. So here, that A turns into A naught because it had to go into the bubble. Now, if I put an A here and a B here on the inputs of the NOR gate, well, on the inside of the NOR gate, this is just an OR. If you notice, that's just an OR without a bubble. So on the inside, this is going to be like an A plus B, and then jumping over that bubble, that's going to turn into an A plus B, but all knotted. Therefore, the output of this gate is going to be not A plus B. Same thing for the NAND gate. If I put an A here and a B here, well, both A and B are going to come into the gate. The gate's going to see it. It's going to act just like an AND gate. It's going to put A ANDed with B here, jump over the bubble, and because it had to get over that bubble, it's going to knot the entire thing. And therefore, what we see on the outside is going to be not AB. Those are the gates. Now, how do we take an equation and actually turn it into a circuit? Well, what we do is first we just start and look at what are our two parts here for this F equation. So this came from the last video, and here we've got an AB and an ORed with an A naught. So first, we can recognize that this here is an AND gate, and this here is an OR gate. Oh, sorry, that's an OR gate, and then right there is going to be a NOT. And finally, on the outside, that's going to be an and that is going to be a NOT. Let's get to it. So let's go ahead, let's do this AND gate here first. So that's going to be A and B, and they're going to come in, they're going to do an AND gate, and then come out. So here I'm going to write AB on the wire to keep track of it. Now, we've got A ORed with it, so I'm going to take this wire and I'm going to jump it down, and I'm going to knot it because here we can see we've got our knot. So build that NOT gate and come out. And now I'm going to bring these two closer together so I can do this OR gate right there. So build that OR gate and come out. So let's put our wire names down. So we've got A coming in here, we've got A naught coming out, therefore we've got AB going in and A naught coming in, so therefore we're going to have AB ORed with A naught. Now finally, I'm going to move this over just a little bit so we can have just a tiny bit more room. AB, and now if I take this B, bring it over here, give it a knot, and then finally AND it like this, we will have our final equation F. That's because, well, we take this B, we can see it's B coming in right here and B naught coming out. And going into these two parts, we can see that AB plus A naught is this part right here, and we can see that this B naught here is right here. So we've made the equation. We've got F is now function of A and B in a circuit. Now let's do G. Well, for G, it's not letting me select that. Oh well. I'll just rewrite it down here. One note sometimes, man. Microsoft's got to do better. We've got C, we're going to AND it with AB, ORed with B not C. Well, we can see that we have an OR gate. So this is an OR. We've got an and we've got another NOT gate right there. We've got an and two ANDs actually. One for each of those. So let's go ahead and let's make that. Now, first I'm going to get these two ANDs out of the way. So let's give it a little more space. So I'm going to have an A, a B, and a C. So first, I'm going to bring these two close together so I can go ahead and AND them. So now this is the AB term. That's that one. We got that done. Now we need to do B not C. So I'm going to pull off of B, make a NOT gate, and this is now going to be B naught. And now C is going to come out. I'm going to bring them close together. So now I can do an AND gate and come off, and this is now going to be B naught C. So now we have this one done. Now we need to OR them, as we can see. So we need to bring these together, build that OR gate, and now we've got AB ORed with B naught C. Finally, for our last step, we got to do this AND gate here on that C. So we just have to pull off of here, bring them close together, build the AND gate, and we're done. And we can say that this is G. Why can we say it's G? Well, because if we look at everything coming in, we've got A, B, ORed with B naught C, and that is the same as this right here. And if we look at the other term, we've got C right here. So this C goes into the AND gate. We've got the AND gate. So therefore, we know that that is the equation for G in a circuit. Now, we didn't really come into any NANDs or NORs. So when would you come into a NAND or a NOR in a circuit? Well, if you remember, a NAND gate or a NOR gate is basically just a NOT in front of an A or B, or a NOT in front of an A and B. So let's make an equation that's got that. Let's do H of A, B. Let's do that equal to not A or B, and let's OR that with A knotted and B. So first we can see that this here can be a NOR gate, and this here can be a NAND gate, and we've also got a NOT right there and an OR right there. So let's build up the OR gate first. So we've got A, got B. All you gotta do is bring them close together, build the OR gate, put the bubble on it, and now you've got NOT A plus B. Now remember, this bubble is basically corresponding to that NOT in front of the parentheses. So that's why we are able to do that, because the NOR just represents an extra NOT. Now let's go ahead, let's do the other term. So we have A NOT and with B, with a NAND gate. So first we have to make the NOT. So I'm going to jump that over, make the NOT. And so we've got A NOT. And now if I pull this B off, I can put these into a NAND gate, and we'll get NOT A NOT B. Pretty simple. Now, all that's left to do is OR them together. Build the OR gate, and now we have H. And that's it. It's that easy. Hopefully you guys learned something. See you in the next video.